Hello guys, and welcome to today's Arduino video, and today we're going to make an Arduino Kill /death /kill streak counter. Now this is a project for video games, and what it's going to do is it's going to count the amount of kills, deaths and kill streaks that happen to your character. You're going to press a separate button for when you kill, when you die and when you make a kill streak, and it's going to keep a record of it on either a 16:2 LCD screen, a 20:4 LCD screen, or if you don't have an LCD screen, the serial monitor on your Arduino IDE. Now today I'm going to actually record a video of me making it because it's quite complicated.
So today guys, you'll need quite a lot of equipment. First off, you'll need the Arduino Uno microcontroller, or any other Arduino really, that's what we're programming it in. This is the Arduino Uno, and it's a very good one for this project because it's very basic and it's everything that we'll need. You'll also need a full-size breadboard, like the one I'm showing here. Full-size breadboard, and also, as well as this full-size breadboard, you'll need a half-size breadboard. This is just a bit of a half-size breadboard that I took apart for this video because I didn't need a full-size one. Okay, as well as that, you will need jumper wires. Now you don't need this, but a 16:2 screen would be good. But even better, and I'll emphasise even better, a 20:4. Because look at the size difference if I put them next to each other. Right? That one's going to be much easier to work with. You'll also need a piezoelectric buzzer. You'll need 4 220 ohm resistors. Now 220 ohm are like orange, brown, gold. I'm colourblind, so that might not be right. This is a 220 ohm resistor. You'll need also a potentiometer, 3 LEDs of different colours. Ideally, you'll have one green, one red, and then one of another colour. I'm using an ultra bright white LED. And then finally, you need 3 generic push buttons. So let's wire up the components. What you need to do is you need to get your LCD screen, you need to plug it right in the end of your breadboard, like I've done here, so that all the pins are right at the end of the first bit of the breadboard. And what you need to do is you need to plug your first wire into ground, your second wire into 5 volts, and your third wire to the middle pin of a potentiometer hooked up to 5 volt and ground on the other side of the 2 pins. And then your fourth pin of your LCD screen is wired to digital pin 12. Let's continue with this wiring now. So let's wire the next pin of the LCD screen. Needs to go to ground. Okay? And then your next pin needs to go to digital pin 11. So if we just zoom in a bit on the Arduino, you can see that there's digital pins 12 and 11. And then if we have a little look at this here, if we look at the pins, so far we've got the first to ground, second to 5 volt, third to the middle pin of a potentiometer, fourth to digital pin 12, fifth to ground, sixth to digital pin 12. Okay, and I did plug these into the wrong ones, but there you go. That's so far. Then you skip 4 places. It's 1, 2, 3, 4. And then the next 4 all go to the digital pins 5, 4, 3 and 2. So your first one will go to digital pin 5. Your next one of that 4 will go to digital pin 4, like this. Your next one will go to digital pin 3. Oh. And then your final one will go to digital pin 2. Okay, so there we go. We've got all of that wired up. And then we've got 2 more connections to make. Now you need to get your 220 ohm resistor. I'm not going to be able to get that to focus in, I don't think. And the second to last pin, you plug into 5 volts via a 220 ohm resistor. Like that. And then your very last one, your very, very, very last pin of your LCD screen will go to ground. So there you have it. That's what you need to wire to the LCD screen. Now I'm just going to wire 5 volts and ground to the breadboard. So here are your 5 volt and ground pins. 5 volt to 5 volt side of the breadboard. No, I've plugged it into the wrong side. There we go. And then ground onto the ground side of the breadboard. Okay, now we need to wire the buttons. So this is where your 3 push buttons come into place that we looked at earlier. You need to plug them into your breadboard here. So just plug them in. And I would leave about 5 spaces in between. It doesn't need to be exact. So a bit like that, I would. Then you should have 3 220 ohm resistors left. 3 220 ohm resistors. And what you do with them is you go to your button, like here, and you go to the left side at the bottom, and you plug them in like this. You just get them and plug it into the blank space in between each button. So just like that. And this is because you can't wire 5 volts straight to ground. So we need to do some sort of resistor. Okay, and then on this side of the resistor, I'll just get a shorter connector pin. On this side of the resistor, we need to have it connected to ground. So on this side of the resistor, we need to have it connected to ground. So I'm going to connect each of these sides of the resistors to a ground on the breadboard. So I'm just going to do this. Okay. So we got that. Then the other side of the speaker, the buttons. So this side here needs to be wired to 5 volts, and it doesn't have to be done through a resistor. So just wire each of these to 5 volts, like so. And it doesn't matter where you wire them on the 5 volts at all, as long as you wire them on the 5 volts. Oh, making a bit of a hash of this. And there we go. Okay, so all the buttons are wired up to the power, but now we need to wire them to the digital inputs, don't we? So the buttons are wired to digital pins 0, 1 and 13. So we need to get 3 more jumper wires, and we need to wire them to this bit where the resistor is attached to. It's not going to focus in, but this bit here where the resistor is attached to on the same side of the button needs to be attached to digital pins 0 for the first button. Oh, so this is the Arduino here. I'm going to do it at side view. Now this camera is not focusing well today. It's This one needs to be at 0. So there. And then your next one, we'll just grab another jumper wire. Your next one needs to go there like on the last one. It needs to be wired to 1. So let me just wire that into 1, like that. And then your final one here needs to be wired to 13. Now it can be any pin on your Arduino, it doesn't matter which pin you wire it to, but I've just selected 3 random pins to wire it to. So if your finger's looking like that so far, you know you have done it correctly. Now let's just hook up our buzzer. So I'm going to put the buzzer about here on the breadboard. I'm just going to slot it in like that. Okay, I'm going to turn this round now so that you can see it from the other side of the buzzer. Now, one side of the buzzer, so this side, needs to be wired to digital pin 8. So we get one side of the buzzer and we wire it, turn it round again. This is getting very complicated now. So we wire that to digital pin 8 and we wire the other side to ground. I'm not actually going to wire that up actually because it's getting quite complicated and I'm trying to hold the camera. Okay, so I also said that you would need 3 different colour LEDs. Now these are going to come into place now because what we're going to do is we're going to put these next to the buttons. So there, then there, no not there, that's why this one, there, and then finally, or not so finally, I haven't wired these in the right places really, in fact I'll just put that one there and then that one there. Okay, so we've got 3 LEDs next to the buttons. One side of these LEDs needs to be wired to some digital pins. Them digital pins are 6, 9 and 10. So we need to wire them to 6, 9 and 10. So that's what I'm going to demonstrate now. So this first one, the anode to 6. So the anode needs to be going to 6 of each one. And then the next one 7. And then the final one, look it for me, final one, here, needs to go to 10. Okay, but it doesn't matter which pins you use really, for which places. Really doesn't matter. Okay, so that is pretty much the wiring. I am going to put a wiring diagram on the screen for you as well.
Let's have a little look at the code involved in this project. The first 2 lines read #include liquidcrystal.h and liquid crystal LCD 12, 11, 5, 4, 3 and 2. Now, whenever you set up an LCD screen, you always have these 2 lines of code. The first one includes the liquid crystal library. The second one declares the pins that we are using on the board that the LCD screen's attached to. And then you need to store the digital read value variables. So I've got 3 lines of code here: int kill, int def and int kill streak. Now later on in the program we're going to use these variables and we're going to say That's going to be the variable that we store the value of the pin in. But we just need to declare them variables exist. Then we need to create 3 more variables, which will increase as the button is pressed. Int kill counter, int def counter, and int kill streak counter. Now when you press the button, these will keep going up and up and up, and they'll change whenever you press the button, and that's what we're going to use as the variable to hold however many times you've got kills, deaths, and kill streaks. The next 3 lines of code read const int kill button equals 0, const int def button equals 0, and const int kill streak button equals 2. These are the pins the buttons are attached to, and they're constants because they do not change. So these are the 3 buttons and the pins that they are attached to, and we've just given them a name. And then the next 3 lines of code read the pins the LEDs are attached to. Read constant kill LED equals 6, constant def LED equals 9, constant kill streak LED equals 10. These are constants because they don't change, and the pins that the LEDs are attached to. So we've declared a load of integer variables in this part of the code. Okay, the next piece of code we're going to put inside a void setup loop. And the first line of code is lcd.begin 24. Now, whenever you use an LCD in the void setup, you always put that, and you're basically declaring the size of the screen. Now, if you've got a 20 by 4 screen, you're going to put 24. If you've got 16 by 2, you're going to put 16 too. And if you haven't got any LCD screen, you don't need to put any of these LCD lines of code at all because you're not going to use them. And then we've got 6 lines of code that start with pin mode. And we're basically declaring kill button, def button, and kill streak button as inputs. And we're declaring them as inputs because we're going to read whether there's electricity going into that pin or not. When the button's pressed, there's going to be electricity going into that pin. When it's not pressed, there's not. And by declaring it as an input, we're setting it so that later on in the program, we can read whether there's electricity running through that pin or not. And then the next 3 pin modes are the LED pins, and we're setting them as outputs because we want to control whether LEDs turn on and off. Therefore, we need to control whether there is current running out of that pin. Because if there is, the LED is going to be on. If it's not, the LED is going to be off. And then finally, serial.begin 9600. This basically starts a serial monitor, tells the Arduino we're going to use the serial monitor, and yet again you only need to put that bit of code if you're using the serial monitor and not the LCD screen. So that's that bit of code. Now we're going to have a look at the next piece of code. So this bit of code is in a void loop because we want it to run over and over and over again and keep checking all of these bits of code throughout the program. So the first line of code that we've put is kill equals digital read kill button. Kill button we've assigned on the other bit of code as an input, and we've also assigned the kill button as 0, digital pin 0. So it's going to read digital pin 0, and then that's what kill is going to be equal to, whether digital pin 0 is high or low. Now we're saying if it's high, kill counter equals kill counter plus 1. What that's going to do is, at the moment, kill counter is 0. If that button's pressed, kill will be high because it's reading the kill button, whether it's high or low. If it's high, it's going to increase the kill counter by 1. So it's going to be on 1. If you press it again, it's going to be on 2. If you press it again, it's going to be on 3. And then when we're turning the LED on, digital write kill LED high, that's what digital write does. So we're saying the kill LED, we need to send electricity out of it, and that's going to light up the LED that's kill next to the kill button. And then it's going to send out a little tone 8 440 200. It's going to send a tone out to pin 8 to the piezoelectric buzzer attached to pin 8. And then it's going to delay it for a fifth of a second, 200 milliseconds. And it's the same for all of them bits. It's saying if def equals high, it does the exact same thing on the def counter. And kill streak equals digital read kill streak button. It continues the same for every single bit of every single little loop of code there where it's an if. So there's loads of if statements. We've got 3 if statements detecting whether there is electricity going inside that pin button. Okay, so now let's have a little look at the next bit of code. Now you may have noticed I've put a comment in there that says written for broken screen where row 2 equals 3 and row 3 equals 2. Now I corrected that bit of code because my LCD screen, I don't know why, doesn't work. But just ignore that comment. I've fixed the code. I just forgot to take that off when I screenshotted the code. So let's have a look at the first line. LCD.setCursor 0, 0. Now you don't have to do it. You may have noticed that there's 2 parts kind of, the LCD and the serial. Now you don't have to put both of these. If you're using the LCD screen, you need to put the LCD bit, and if you're using the serial monitor bit, if you're using the serial monitor, just have the serial monitor bit. So LCD.setCursor 0, 0, so we're setting the cursor to the first box on your screen, ready for it to write, and then it's going to print kill/def counter. So that's just like a little title for the screen. I've written this code for a 20x4 screen. You will just have to modify the code ever so slightly to shrinkify it a bit and get rid of parts and try and fit it onto 2 lines if you're using a 16x2. But I've written this for a 20x4. So it's going to put on the first line kill/def counter, and then it's setting the cursor to the second line, LCD.setCursor 0, 1, and then it prints kills with a colon. And then I've put plus kill counter. What that's going to do is it's going to put on the screen kills, and then it's going to put it's going to have a live stream or a live update of how many kills you've made. When you press that button, it'll go next to the kills because that kill counter is a number, so it's just going to put that number after kills. And it's the same with the next one, LCD.setCursor 0, 2. And then it sets deaths, and then puts the amount of deaths, and then on the next line, the final line of your LCD.setCursor 0, 3, it prints kill streaks, and then the amount of kill streaks you've made. And then if you're using the serial monitor, we've just got printed on 4 different lines, your kills, your deaths, and your kill streaks, and you might want to get rid of that first line if it annoys you because it's not really necessary. And then at the end you just put a delay of 1000. So you might have noticed it's not going to run that smoothly. It's going to have maybe a second or 2 delay to have the LED, the button, and the LCD screen update. So in that respect it's not very efficient, but that could be a good challenge for you to complete. Try and make the code more efficient. If I reach 1,000 subscribers, I will post a new video every day.